Hello and welcome to another video. In this video we're going to be working on length of longest subarray with at most k frequency. And in the problem you're given an integer array nums and an integer k. The frequency of an element x is the number of times it occurs in an array. And we want to return the longest contiguous array where the frequency of each element in the array is less than or equal to k. And so this is what they tell you. So the first thing you want to look for, we're going to go through the examples, but when they tell you look for a contiguous array, the first thing you want to look for, especially when the constraints are pretty bad, right? Like anything worse than n squared will, or anything worse than n log n will fail. You want to look for a sliding window or two-pointer. So let's take a look at this. So here, the longest possible good subarray is 1, 2, 3, 1, 2, 3, where every single element has length 2. And there are some other ones, but there's nothing bigger than that. And the second one, k is 1, so we have to have a subarray where every element has length 1, so obviously it's just going to be like 1, 2, or 2, 1, and so on. And in the third one, k is 4, so the longest subarray is going to be like this, any one of these combinations. So this is actually a lot easier problem than is usually given on like a weekly contest or bi-weekly contest third problem. I think the last few I've done were significantly harder, so kind of interesting. But in another case, all we really need is to maintain the count of every single element. So we can just maintain a count of elements to know if our array is valid, right? To know if array is valid. So let's actually make an array, and let's kind of walk through how this is going to go. So let's take something like this. Maybe, yeah, let's do something like that. And then let's say, let's make a k value. So let's say k equals like 2. And let's just put in some values here. And we'll kind of walk through exactly how it's going to go. So let's just say we have like 0, 1, 0, 2, 3, 2, 2, 5, 5, 5, something like this. So essentially, we're just going to walk through our array and we're going to maintain a count. And whenever our count of the current element, we're always going to maintain an array that's valid, right? With a sliding window, we're always going to maintain an array that's valid. Therefore, whenever we hit some element and the count gets bigger than 2, then we know that's the element we have to decrease because every other element is valid. And then once our sliding window is valid, we can just maximize our result. So we'll have like a result over here, make it like 0 to start off, and then we'll go through it. So let's have 2 pointers here. So we'll have one over here. And actually, let's delete this. So yeah, let's make one like this. Okay, and let's make one more. Yeah, let's make one more, and let's make it another color as well. So this is going to be the right pointer is going to be the blue, and the left pointer will be like the green or something. So we'll make a green one like this. Okay, there we go. So essentially, we're just going to walk through our normal sliding window, and we're also going to maintain counts here, right? So we're going to walk through 0, and we're going to say, okay, what's the count of 0? This is the first 0 we've reached, so it's going to have a count of 1. Then we're going to move our right pointer over here. And also, anytime we do this, we're also going to maintain, like, what's the biggest array we found. So we did find an array of 1, right? Because it's just this 0. Then we're going to move the right pointer, and we're going to say, okay, what's the count of 1? So the count of 1 is just 1. We haven't seen it before, and this is still valid. So now our result is 2. So we'll change it to 2. Then we're going to move our right pointer again. And we're going to see, okay, it's a 0. We had a 0 before, so we're going to update the count to 2. Still less than or equal to k, so totally fine. Now we're going to update our result to 3. So let's do that. Then let's keep going. So we're going to go over here. We're going to say, okay, we have a 2 now. Do we have a count of 2s? No, we don't. So we'll add a 2 with a count of 1. Perfect. This is valid. So now we're going to change this result to 4. Then we're going to keep going. So we're going to find a 3. And we're going to say, do we have a 3 yet? No, we don't. So 3, value of 1. Totally fine. Get rid of that. Now we have an array of like 5. Now we move this again. So we hit this 2. And we say, okay, we have it. And so now we're going to update the count to 2. And once again, totally fine. Our element is less than or equal to k. So this is a valid array. So this is length 6. So we will update it to 6. Then we keep going. So for this one, we have a 2. And now this is our first issue, right? We have a 2 with a count of 3. So now we know, because every other value is valid, we know that like this value is too big. So while it's too big, we have to decrement from the left until it meets this k. So we're going to decrement from the left. So we're going to decrement. We're going to get rid of this 0. So this count will be 1. Move this over. Decrement from the 1. The count will be 0 now. Then go over here. 0. Count of 0. We basically have to do it until we hit a 2, right? So now we finally hit a 2. So we're going to decrement here. And then move it over here. And now this is our new valid sliding window. So this is all gone. Now this is our valid sliding window with a length of 3. Then, now that it's valid, once again, we write down our result and we just keep going. So we're going to hit a 5, and we can speed this up a bit. So we're going to hit a 5 with a count of 1. Then we'll move it over, hit a 5 with a count of 2. Then move it over again and hit a count with a 5 of 3, which will be invalid. So what we need to do is we need to, once again, keep decrementing from the left until we hit a 5. So we'll decrement over here. So this 3 will have count 0. We're going to get rid of both of these 2's so that these 2's will have a count of 0. And we decrement the count of the 5 now over here. And that's basically it. So you could speed this up a little bit by saying anytime you hit something with a count equal to k, just keep going until the left is whatever value you have, right? So let's say we hit a 5 here, and we say like, okay, if the count is k, let's just keep decrementing left until we hit a 5. So either way, it's fine. Or you can just like increase the count and then decrement until the count is matching. So it's essentially a really easy sliding window. Just to sum it up, just have a count once cur L element count is greater than k, keep shrinking window until count equals k, and then for valid window, calculate result, which is just right minus left plus 1, normal sliding window length, standard stuff. And yeah, that's pretty much it. So now we can code it up. So we'll have a left, 0, result 0, count. We'll just have a default dict. And we just essentially walk through our array, right? So we're going to say for right in range like nums, count nums right plus equals 1, and while count nums right is greater than k, if it is, let's just keep shrinking, right? So we'll just say count nums left equals 1, increment left. Keep doing that until our count nums right is less than or equal to k. If our count is already less than or equal to k, we just wouldn't enter this loop at all. So this loop basically just maintains that our array after the loop is valid. Then we just simply check the result. So we'll just say result equals max of result and right minus left plus 1 and return it. And yeah, a surprisingly easy problem for a contest third problem. Haven't done the fourth one yet, so we'll see how that goes. But yeah, this one very easy. So hopefully you enjoyed this explanation. And definitely, I think if you are doing these contests, I think this kind of problem should definitely be one you should be able to do. Like I'd say even the one before this was harder, to be honest. So yeah. Oh yeah, let's go through the time and space. So as usual for pretty much all sliding windows, time is ov(n), and space ideally you want to have an ov1. In this case, we weren't able to make it an ov1 space, so I think it would actually be ov(n) space, because let's see what our numbers, yeah, so our numbers can be anything, so this is just going to be ov(n) space. So you have to maintain this count, and the numbers can all be different, so worst case scenario, you'll just have a cache of n items. Like let's say your numbers were all different, like, you know, like 1, 2, whatever the length of the array, then your space would be n. So you can't really do ov1 in this case because you have to have a count, but in most sliding windows you can do ov1. Yeah, so that's going to be all for this one. Hopefully you liked it. If you did, please like the video, subscribe to the channel, and thanks for watching.